Here's part 3 of your guys' spring final. This is part 3. This will be going through numbers 26 through 34. Okay? Alright, 26. 6 books need to be placed on a shelf. You randomly arrange the books on the shelf from order from left to right. So if there's 6 books, you need to put them from left to right. That means there's just a certain amount of possibilities you can put for each slot, right? So in the first slot, there's really just 6 possible combinations you could put in that one slot, then 5, then 4, then 3, then 2, then 1. So if you multiply all that together, that's going to be 720, so that's part D. Now for 27, it says a jewelry store sells gold and platinum rings. So gold and platinum, right? There's 2 types of that. Each ring is available in 8 styles, so there's 8 styles, right? And it's fitted with one of 8 gemstones. So combinationally, that's 2 times 8 times 8. So that's going to be 128. 28. When a button is pressed, a computer program outputs a random odd number greater than 1 and less than 13. You press the button 5 times. So essentially, for each button, there's going to be an output that's either going to be 3, 5, 7, 9, or 11, because that's all the odd numbers between 1 and 13. So you have 5 options every time, right? So if you press the buttons 5 times, that means for each time you press a button, there's 5 total combinations every time. So that's just why it's 5 options times 5 options times 5 times 5 times 5, which is 3,125. 29, a spinner can land on either red, blue, or 3. So, right, if you do a spinner, there's 3 total outcomes. And if you spin it 5 times, that means for each outcome, so each time you spin it, there's 3 outcomes possible. And if you do that 5 times, that's 3 options times 3 options times 3 times 3 times 3. So that's 243. Number 30, same thing as 28, except now it just adds one more. So there's 5 options for the button, and basically you've pushed the button 6 times, so that's 5 options times 5 times 5 times 5 times 5 times 5. So 15,625. Alright, so 31. Now, in this one, a chemistry lab requires a student to identify chemical compounds by using various tests. Each student is giving samples of 3 different compounds, labeled A, B, and C. Each student is also given a list of 12 possible compounds. If a student does not perform the test and randomly chooses 3 from the list, what is the probability that she guesses all 3 correctly? So, pretty much there's just 12 different types of things, right? And she has to guess it correctly each time. So if she guesses the first one correctly, right, there's 12 different types, so that means she has 1 in 12 chance to guess that specific one correctly. Then when she guesses again, there's 1 already gone, so that means there's 1 out of 11 chances she gets the next one correct, and then 1 out of 10. Multiply all those together and you get 1 over 1,320 for C. So remember, so if you guys actually divide that, I think that's going to be like 0.00076, but remember, to get it to a percentage, you got to move the decimal place over 2 to the right. 32. Mechanic working under a car requires 4 different size wrenches for his toolbox, which contains 11 different wrenches. Reaching for his toolbox, he grabs 4 of them at random. What's the probability that the mechanic has all the wrenches he needs? Okay, so essentially, when he selects a wrench out of his toolbox, he just needs to select all 4 of the ones that he needs, right? So the first time he picks out, he has 4 out of 11 chances of selecting a wrench that he needs. Then when he goes back in the bag, assuming he picked the right one the first time, now there's 3 out of 10, then 2 out of 9, then 1 out of 8. So multiply all those together, and then you're going to get one. Well, even if you multiply all those together, you're going to get 24 over something. 24 over 11 times 10 times 9 times 8, 7,920. So 24 divided by 7,920 is going to give you around 0.00303, but remember you gotta move the decimal place 2 over to the right for the 0.303%. Alright, 33 and 34. Okay, so for 33, a jar contains 5 black buttons and 7 brown buttons. If 7 buttons are picked at random, what's the probability that at most 3 of them are black? So, first you guys have to know what is the total amount there are and how many total picks does this person do or whoever. So in the denominator, it's 12, choose 7, because 12 is the total amount in buttons, 7 is the total amount of choices that you are making, or picks. Now you have to think of what they are specifically asking you. They're asking for at most 3 of them are black. So that means if you're trying to find all the combinations that at most of them 3 are black, that means you could do a scenario where they do not pick any that are black, they choose 1 that is black, they choose 2 that is black, or they choose 3 that is black. So this case right here represents choosing 0 black buttons. Now, if you choose 0 black buttons, that means the other 7 buttons must have been brown. So that's why this is 0 for 0 black buttons, this is 7 for 7 brown buttons, and since there's 5 black buttons, that one's 5, and there's 7 brown buttons, so that's 7. So that's the first case. Now you gotta do the second case. If you select 1 black button out of the 5, then that means you must have chosen 6 brown buttons out of the 7 brown ones. Then you gotta do, okay, if you choose 2 black buttons out of the 5 black buttons, that means you must have selected 5 brown buttons out of the 7. And then if you chose 3 black buttons out of the 5, that means you must have chosen 4. And notice, you guys, that the totals will add up. So 5 black buttons and 7 black buttons add up to the total of 12. And if you choose 0 black buttons and 7 brown buttons, the total of that adds up to the 7 you chose. So 1 and 6 and 7, right? Those add up. 2 and 5, so that's another way you check. So then you guys plug this all into your calculator, and then you should be able to get that percentage. Alright, 34. Okay, this one. Technicians launching fireworks near the end of a show. Of the remaining 14 fireworks, so I already know there's 14 fireworks, which is why the denominator, all of these are 14, because that's the total amount of fireworks, 14. 7 are blue, and 7 are red. So that's why I put 7 there and 7 there, because that represents the total fireworks for each color. He launches 6 of them. So out of the 14 fireworks total, he launches 6 of them. So that's why these are all 6, because that's the total amount that he launches. So total amount of fireworks total and the total amount of fireworks he launches. What is the probability that at least 2 of them are blue ones? So at least 2 of them are blue ones means he could have launched 2 of them, he could have launched 3, 4, 5, or 6. So this is a scenario. If he launches 2 blue ones, he launched 4 red ones. He launched 3 blue ones, 3 red ones. Launched 4 blue ones, 2 red ones. Launched 5 blue ones, 1 red one. And launched 6 blue ones, and he must have launched 0. So that is the setup. And then pretty much it's just putting it in your calculator and calculating all that, and you should have gotten 94.872%. So that concludes part 3 of the final. Just one more video after this for part 4.